Good morning, everyone. My name is Ashish Biswas, and I am a third year student of Electronics and Communication Engineering Department at Coachbihar Government Engineering College. Today, I am going to talk about an essential topic in the field of digital communication and stochastic, which is passcode modulation or PCM. Throughout this presentation, I will discuss the principle behind PCM and its implementation process. Now, introduction to PCM. Passcode modulation is a method of converting an analog signal into digital format. In PCM, the analog signal is first sampled at regular intervals. Each sample is then quantized to the nearest value within a set of discrete levels. Finally, then quantized values are encoded as a binary sequence of zeros and ones. As shown in the block diagram of PCM, the process begins with the analog in message input, which is first passed through a low pass filter to limit the signal bandwidth. Then the filtered signal is then sampled at regular interval to capture at amplitude at discrete points. These samples are sent to quantizer, which assigns each sample in a specific value from a finite set of levels. Finally, the encoder converts these quantized values into a binary format. Now let's talk about the quantization process. Quantization is a fundamental step in passcode modulation where each sample value of an analog signal is mapped to the nearest value within a predefined set of discrete levels. This process is necessary to convert the continuous signal into a digital format of further processing. In the diagram shown, you can see the effect of different quantization levels. The top diagram represents a signal quantized with 16 levels, while the bottom one just 4 levels. Notice how the 6-level quantization more accurately tracks the original analog signal compared to the 4-level quantization, which introduce a more significant deviation. This deviation, also known as quantization noise. Now, for calculating the bandwidth of PCL, first we should determine the maximum frequency of the analog signal, which is represented by FM, by identifying the highest frequency component present in the analog signal. Now, we have to calculate the sampling rate, which is Fs, and the formula is given. Then we should determine the number of quantization levels, L, which is typically 2 to the power V, where V is the number of bits per sample. Now calculate the number of bits per sample V. Uh, we can use the relationship between the quantization level L and bits per sample V. The formula V is equal to log 2 L. Now we should calculate the bit rate. The bit rate is R, which is the number of bits transmitted per second, and the formula is given. Now, calculating the transmission bandwidth, uh, we have given the formula where bandwidth is less than equal to half into V into Fs, where V is the number of bits per sample and Fs is the sampling rate. Now let us talk about the signal to quantization noise ratio SQNR. Signal to quantization noise ratio SQNR is measure of the quality of quantized signal. It is defined as the ratio of the power of the original signal S to the power of the quantized noise N.